Hi there. So I'm going to talk about this paper by William Hamilton, Leskovec, and Jurafsky, where the central question they're looking at is how do word meanings change over time? Start off, they give us this example of cast versus cat, where you can see cast takes on a dynamic range of values. Cat is much more stable. So these word embedding methods we're going to look at, they all rely on this distributional hypothesis that semantics are implicit in co-occurrence relationships. And these authors are going to use a context window of size 4 to look before and after each target word. So there's 3 algorithms that these authors look at. The first is PPMI, positive pointwise mutual information. Essentially what this does is constructs an enormous matrix, the number of words by the number of context words. And for each, it gives a measure of the mutual information. So the amount that the probabilities, how they relate to each other in information theory. Second, we have a dimension reduction technique on that big PPMI matrix. This is singular value decomposition. It's really common. They truncate at 300 features to create a much smaller matrix. And finally, we have the SGNS, skip-gram negative sampling algorithm, which comes from the team at Google in 2013. Colloquially, the word-to-vec algorithm. This is using a neural network to predict actually the context words from the target word. The data that we have, they're the authors using, partially comes from the Google Ngrams data set, which is enormous. It's about 6% of all books ever. Potentially contains some sampling biases over time. Then there's also the COA corpus, which is the corpus of historical American English. This is much smaller, but it is balanced between the different decades, trying to be representative of American English. So the data processing steps that the authors take, first they split these data by decade, then they create these word embeddings using the algorithms I was talking about earlier. They align those word embeddings over time so that you can then calculate these metrics using cosine similarities between words and also within the same word over time. So there are a few different tests that they use to kind of validate their methods here. One is within decades, which method kind of matches best human judgments of word similarities. Then diachronic validity, they're looking at detecting shifts and discovering shifts from the data. And you can see the PPMI doesn't do very well. The SVD and the SGNS kind of split the rest of the tests, and they're going to use SGNS for the rest of their work in this paper, which is going to be looking at, can we discover any big picture laws of how words change over time? So in general, we're looking at frequency and polysemy, where polysemy refers to multiple distinct meanings. So a word like cast having multiple distinct meanings. The first thing to notice is these are correlated frequency and polysemy. So a word that is more frequent is also likely to have multiple distinct meanings. So the authors are going to separate out the effects with mixed effects log-log regression. And I'll go through that one step at a time. On the left-hand side of the equation, we have the semantic drift from one decade to the next. This is the cosine similarity between a word and itself, not including stop words, only words with 500 plus appearances in both decades, log transformed and normalized. Then we have the frequency and the polysemy measures. The frequency is self-explanatory. Polysemy is operationalized as contextual diversity, and they're actually using a clustering coefficient in the co-occurrence network to measure that. Then we have decade fixed effects and word-specific random intercepts, which are included to capture any correlation between a word that's measured between 2 decades and then a later 2 decades, probably going to be correlated, which is going to screw up the estimation of the regression. So we have to include these random intercepts to capture that. So the authors come up with these 2 statistical laws of semantic change. First is the law of conformity, that frequently used words change at slower rates. And the second is the law of innovation, that polysemous words change at faster rates, all else held equal. Now notice that both of these laws are in the form of a power law with positive or negative coefficients, depending on which one. That's because of the log-log setup that the authors used. So this is a chart that they include. It's a pretty interesting result to be able to identify what does it mean, or what does it mean for semantic changes if a word is more frequent or it's more polysemous. A couple extensions I was thinking about. The first is, instead of stratifying a data set by decade, if we could stratify potentially by reading level and then learn about when do words become more polysemous and how did the embeddings change as reading level increases to learn about learning. And then I was wondering if we could detect corpus level biases by comparing embeddings between two different corpora. And I think that that's been done a little bit in some recent work. So pretty interesting stuff. Thank you for listening.